I wanted to do some sample problems with you today. I just wanted to go over how to use this mole roadmap in order to complete your stoichiometry calculations. So depending on what your given quantity is, most often you would be given a quantity in mass because that's what's being measured in most of the time. Sometimes it'll be given to you in moles and sometimes volume. It will very rarely be given to you as representative particles, which is how many actual atoms or molecules. This is not very common. If you have either of these, you have to convert them to moles first. And if you're given moles, then you can go right to the middle part. This ratio is what allows us to transfer from one substance to another. It is the mole ratio. These coefficients come from the balanced chemical equation. You must have that. And then after that, you can then take your substance. We've converted it to the wanted quantity. And if you want moles, you're done. If you want mass or volume, you need to convert it. Or if you want particles, again, you would need to convert it. So you figure out what you start with, and you follow through to the other side until you find what you end with. Now let's use this and complete 3 questions together. These questions came from the Khan Academy questions that I'm going to be assigning from you. So follow this, take notes, and if you would like to, then you can practice them on your own. So given the following reaction, magnesium hydroxide plus hydrochloric acid yields magnesium chloride and water. So how many moles of MgCl2 will be produced from 65 grams of MgOH2? So this is what we're given, and we want to find this, how many moles of this. This is our wanted quantity. We're starting with grams, and we want to find how many moles. So let's just check out our little roadmap so we can see. We're starting with grams, and we want to end with moles. Grams of our given amount and moles of our wanted amount. So we're going to take our grams and convert to moles. Then we're going to use the balance reaction to convert, and then we will have moles of our wanted amount. So, the first conversion, we're going to write down our grams of MgOH2. So we have 65 grams of MgOH2. Now the first thing we have to do is convert that to moles, and to do that we need the molecular mass of MgOH2. So molecular mass will be 1 mg plus 2 O's plus 2 H's. I'm going to write these out. These numbers come directly from the periodic table. Magnesium is 24.305. 2 oxygen, that's 2 times 15.999 plus 2 times 1.008. And we would add those together. Oops. There you go. 58.319. And that is grams per mole. So our first conversion involves canceling out the grams and getting moles. So we have 58.319 grams of MgOH2 for every 1 mole of MgOH2. So we're going to divide by that to get our moles of MgOH2. Now, instead of doing this as separate steps, we can just kind of piggyback all of these parentheses right off of each other. So the next one we're going to convert is going to be this mole-to-mole ratio. because now that we have moles of the first substance, we have to convert to moles of the other substance. So we get the coefficients from the balanced reaction. And the coefficients here are 1 and 1, so we actually don't have to do anything but write them in. So that means 1 mole of MgOH2 will create 1 mole of MgCl2. It's a 1-to-1 ratio. So when I type this into the calculator, all I have to do is 65 times the top divided by the bottom times the top divided by the bottom. And I know you're thinking, well, do I really need to multiply and divide by the 1? No. You could skip those. Because you know mathematically, when you multiply or divide by 1, it does not make a difference. So just type in 65.0 divided by 58.319. And there's our answer. 1.11. Now we're going to round this to 3 digits because we were given 3 digits. 1, 2, 3 digits of given. So 1.11. We're going to round it right there. So our answer is 1.11. What are our units? Let's check. Grams of MgOH and grams of MgOH cancel. Moles of MgOH and moles of MgOH cancel. And we're left with moles of MgCl2. And that's what we want. How many moles of MgCl2? So our answer is 1.11. Okay, we're going to do the same thing again. I'm going to move a little bit faster this time. Pause the video if you want to try it yourself and see if you can get the answer. Given the following reaction, 4Fe plus 3O2 yields 2Fe2O3. How many moles of Fe2O3 will be produced from 18 grams of Fe? So 18 grams of Fe. This is our given. And we've been given grams. And what do we want to find? We want to find moles of Fe2O3. So wanted moles. Okay, in order to do that, we're going to start with our given amount. That's the 18 grams of Fe. Now the first step is to convert the grams of iron to moles of iron. In order to do that, we need the molar mass, which is right from the periodic table, and this is just an iron atom. So I'm just going to use 55.845 grams per mole. That is the atomic mass of iron. So in order to cancel grams, I have to put grams on the bottom. 55.845 grams iron per every 1 mole of iron. Now we have to convert from moles of iron to moles of iron oxide. So when we put this in, this one's a little bit more complex than the other one. We want to cancel out moles of iron, so I'm going to put moles of iron on the bottom, and we want to get moles of iron oxide. You might be wondering what numbers go here. They are simply the 4 and the 2. The 4 goes with the iron, so the 4 goes in the denominator, and the 2 goes with the iron oxide in the numerator. So 18 times 1 divided by 55.845 times 2 divided by 4. .611, and we're going to round that once again to 3 significant figures. So 161. What are the units? Grams of iron cancel, moles of iron cancel, so we get moles of iron oxide. There's our answer. Let's do one more. Once again, pause the video as you go so you can try it yourself and then see my correct answers. Okay. Anytime you see something like this where it says assuming O2 is available in excess, that means that you don't even have to worry about calculating it because there's enough there. So we want to find CO2, wanted moles. We are starting with 20 grams of CH4, given grams. First we need the molar mass of CH4. That's 1 carbon plus 4 hydrogens (16.043), and that's grams per mole. Let's set this up. 20 grams of CH4. Let's convert that to moles of CH4. So we're going to cancel out the grams. 16.043 grams of CH4 for every 1 mole of CH4. Grams cancel. Now let's convert moles of CH4 to moles of CO2. The coefficients here are 1 and 1 again. So it's 1 mole of CH4 will produce 1 mole of CO2. It's a 1-to-1 ratio. So 20 times 1 divided by 16 times 1 divided by 1. And we'll get our answer. .25. I'm going to round that up because 1, 2, and 4 are the first 3 digits, and it followed by a 6, so I'm going to round the 4 up to a 5. So 1.25, and that is moles of CO2. We will go over these more in class. We will practice more of them, but this is just a video that you can refer back to whenever you need to. Thank you.